Hello. I hope you guys are having a good day. We are going to look at the second part of 2.1, which is absolute value and converting that to piecewise and understanding what the definition of absolute value means. Then we're going to look at graphing some absolute value functions. So in the previous video, we looked at graphing piecewise functions, what piecewise functions are, and how they are different functions put together to create one overall function. And I showed you a real-world example that can be modeled with a piecewise function. And in this case, we're going to look at a special type of piecewise function called the absolute value function. The definition of absolute value, and this is really important, says the absolute value of x. Well, as you recall, for example, the absolute value of -2, you've always known, comes out to be 2. The absolute value of 2, you've always known, also comes out to be 2. And the reason behind that, you recall the definition of absolute value being the distance a number is from 0 on the number line. And distance is never negative. So here I have -2, I have 0, and I have +2. So both their distances are 2. So we're going to use this knowledge here, that the absolute value of -2 is 2, and the absolute value of 2 to help us define the absolute value of x, or write the definition. The definition states the absolute value of x turns into a piecewise, notice the piecewise always had the swirly braces as well. The absolute value of x turns into x, meaning that the inside stays the same as long as my inside is positive. Notice if my insides are positive, I get that exact same thing out. So it's going to stay the exact same if x is greater than or equal to 0. You always put the equality part with the one where it's staying the same. And you're going to see in a minute, there's different types. We do the opposite of the inside. So notice that if my inside is -2, it actually comes out to be the opposite of that. So I say the opposite of x if x is less than 0. Notice that if x is less than 0, meaning -1, -1.5, -10, the absolute value of that is going to come out to be the opposite of -5. And I'll show you. All right, we'll practice what that means before we move on. So let's look at some examples. So the absolute value of 5. The absolute value of -5, rather. The absolute value of -5, you know, is 5. But notice that it was negative inside, so I actually do the opposite of the inside. So opposite of insides. Let's look at number 2. The absolute value of 3, you know, is 3. It's the same. And the reason is it was positive inside, so I keep it the same. It was negative inside, so we did the opposite to actually take the absolute value of it. All right, let's take it up a step. Let's say the absolute value of x, of -x, and we're going to say that x is greater than 2, greater than or equal to 2. So let's practice finding the absolute value of this if we know that x has to be greater than or equal to 2. So you have to think if I plug in numbers 2 or greater, let's test them out. So if I plug in 2 for x, I get negative 2. If I plug in 10, I get negative 10. We're plugging in numbers greater than or equal to 2 for x. And so you know that this actually comes out to be the opposite of the inside. Notice the absolute value of negative 10 comes out to be 10, or the opposite of the inside. And the reason is because when I look at values in this range compared to what I have inside, I get negative values inside. When we get negative values inside, it comes out opposite. So to write our final answer, this was just testing some values, okay? We want to actually find the absolute value of negative x if this is the case, if all my values are from 2 to infinity. So I'm actually going to do the opposite of the inside. So it's going to come out to be x. And once again, notice that the reason is, if I let x be 2, then I get negative 2 inside. X is 2, but that negative sign was in your problem, so it comes out to be 2. But anyway, once again, test values in this and think, do I have negative inside? If so, do the opposite of the inside. So I'm going to say the opposite of negative x, which comes out to be positive x. I know that's it's kind of confusing, and it's hard to wrap your mind around it at first, but the more we do it and the more you practice it, the better you will get at it. Okay, so what that says in just, if the number or expression inside is 0 or positive, the absolute value is just the insides. So for example, if the inside is 0 or positive number, then your absolute value answer is just whatever's in the inside. If the number or expression inside is negative, then the absolute value is the opposite of the insides. So my expression inside was negative. I actually do the opposite of that and get 2. So let's practice what we just learned. So just open up your mind and try to absorb this the best you can. Use the definition of absolute value to write the following without absolute value bars. In number 1, we have inside x plus 4y. So this is what we're trying to determine. Am I taking the absolute value and getting x plus 4y? Or am I taking the absolute value and getting negative x minus 4y, the opposite? And how you determine that is based on what they give you. So you're given that x is negative 6. So let's just think, if I take negative 6 and plug in for x, and take y and take 2 and plug in for y, do we get a negative inside or do we get a positive? So do you get a positive or do you get a negative? And negative 6 plus 8, that's going to give us a positive. So we get a positive inside. Since we get a positive, so everything stays. All we're doing right now is just practicing, once again, rewriting the expression inside without absolute value. So we're either keeping it the same or we're changing all of the signs. Based on, once again, do we get a positive value inside or do we get a negative value inside? So you're not actually going to tell me like, okay, well, I get the absolute value of 2, which is 2 here. You're actually just going to rewrite this expression based on what they do give you. So since it's positive, so it stays the same. So the absolute value of x plus 4y is going to be x plus 4y. Okay, number 2. They give you the absolute value of x cubed, and you're told that x, for all the values where x is less than 0, this would mean that we're dealing with negative numbers or negative values. So you first have to determine, is the inside going to be positive or negative? And let's test some values. So we can test some and think about it. If I plug in like -1 and cube it, then I'm going to get -1. If I plug in -10 and cube that, I'm going to get -1000. So notice that my inside is negative. And you don't actually have to show this. You can think about this mentally, which is what I would prefer you to do. I want you to be able to say, okay, well, those are negative numbers. That means that my inside is always going to be negative. If I plug in negative numbers and cube them, raise them to the third power, I'm always going to get negative. So my inside's always going to be negative. So I do the opposite of the inside, which is going to be negative x cubed. Number 3. And I'll go ahead and go back and look at number 2. Another quick way to help you with odd exponent, if I raise a negative value to an odd exponent, it's always negative. And in number 3, notice that my exponent is even, and they also tell me I'm dealing with negative numbers, or x, the values of x are all going to be negative. So think about it, mental math. Use the mental math. If I plug in any negative number and I raise it to the 6th power or any even power, I always get a positive. So the inside is going to be positive. And once again, you've got an even power. But you can test it out, like -1 to the 6th power, that's going to give you +1. -2 to the 6th power, that's going to give you +64. And so you get positive, so it stays the same. So positive stays the same, so you leave it x to the 6th. All right, on number 4, 8 minus square root of 50. You can type in your calculator square root of 50, but notice that 50 is really close to 49, which is a perfect square. So this is 8 minus 7 point something. Square root of 50 is 7.07. So you need to think about that. 8 minus 7 point something. Is that going to give you a positive number inside or a negative number? That will definitely give you a positive. The insides are positive. So I leave this. So 8 minus root 50. I don't have to change anything. On number 5, same thing with root 6. Root 6 is over the square root of 4, which you know is 2. So square root of 6 is definitely 2.2 something. And if I say 2 minus 2 point something, this is going to give me a negative inside. So the insides are negative. And that means you do the opposite. So watch this. All I'm going to do is take this is what it actually looks like mathematically, but I'll show you. So we're going to do the opposite of everything. In other words, you just simply change the sign of everything in there. So I'm going to change 2 to become negative. This becomes plus root 6. So when you get negative insides, change the sign of every term. Now, you can also write this as root 6 minus 2, and that's the same thing. Number 6. I want you to think about this. Notice that it does not give you any values of x, but it tells you x squared plus 2. So this one is stretching your brain. Excuse me. X squared plus 2. Recall we stated if you take any negative number and I square it, I will get a positive value no matter what. So we know that this is always positive here, the x squared, and then I'm adding 2. So this makes it more positive, if that makes sense. So I know no matter what, whether x is negative, positive, I'm getting a positive value here. And then I'm adding, so it keeps getting more positive. So to take the absolute value of x squared plus 2, this simply comes out to the same thing, x squared plus 2. Since my insides are positive, it stays the same. If my insides are negative, it all changes. Number 7, you've got pi minus 4. Recall that pi is 3.14. So if I say 3.14 minus 4, then I'm going to get a negative value. So 3.14 minus 4, this gives me a negative inside. And this is the way, I don't want you to actually give me the value of that, okay? I just want you to rewrite it. So remember, we're going to change the sign of everything. So pi becomes negative pi, 4 becomes plus 4. And once again, you can also write that as 4 minus pi. So that was just to get you used to absolute value, the definition of it, and what it means. That it says if you have positive insides, it stays the same. If you have negative insides, you change it. Okay, a number line illustration. You actually have number 1 in your homework on the absolute value part that is very similar to this. They give you a number line and then they just label these values. Notice that they give you 0, of course, is in between them, which means that B, F, and D are all negative values. And thus C, A, G, and H are all positive values. In part A, they want you, or part ABC, they want you to rewrite these expressions without absolute value using what you know. So if I'm finding the absolute value of D, the absolute value, you're actually taking the opposite of a negative number. D is negative, so I'm going to say that this comes out to be the opposite of D. If D was on the positive side, you would just say D. Because remember, if the insides come out to be negative, we do the opposite. If the insides were positive, we would keep it the same. And I'll show you a reason behind that. Here's a proof for you. Okay, if we have 0 and then let's say negative 2. And I said, okay, let's do the absolute value of negative 2. Well, the absolute value of negative 2, you know, comes out to be just 2. It is the opposite of negative 2. So the absolute value of negative 2 is actually the opposite of negative 2, which is 2. So that's kind of what this, or that is what this means. Part B, you have absolute value of C minus A, so we have to determine, based on what we have, are we getting a positive inside or a negative inside? So let's look. Notice that A is farther than C to the right on the number line, which would mean that A is greater than C. So let's think about this. If you have a smaller number minus a larger number, will you get a positive or will you get a negative? You will definitely get a negative inside. So negative inside. And once again, that would be like if I had 1 minus 2. You're going to get a negative value. So we change it. Negative C plus A. Change everything. Or, once again, you can say A minus C. Part B, absolute value of B minus D. We look at where B is at. B is a negative number. B is a negative number minus another negative number. So that means this is going to turn into a positive when you have minus and negative. So let's give an example. All right, notice that B is farther to the left than D. So let's say that I've got -3 and then I'm going to use -1. Let's let B be -3 minus -1. That turns into -3 plus 1. So you've got a smaller number, or if you want to think about it in this way, a bigger negative number, which is technically not correct, but you've got a very small number minus another negative number. So that's always going to give you negative inside. So we change it. So this becomes -B plus D, or D minus B. So once again, I'm going to get this example, B was farther to the left than D. So I just said, okay, I'm going to use -3, -1, just to see what happens. So -3 minus -1, that will always give me a negative inside. So then I change and get -B plus D. Okay, the next part, we're going to look at how to rewrite absolute value into piecewise functions in order to graph absolute value. So what we just did was getting you used to the definition. Now we're going to take it up even further, and we're going to learn how to rewrite an expression that's not clearly defined, such as the previous examples. And what I mean by clearly defined, look at x plus 2 here in the bottom left corner. Notice that it does not tell you that x is less than 0, x is greater than 0. That's what you have to come up with on your own. So we're actually taking an expression and we're going to create it into a piecewise and define it using the absolute value definition. So here's your steps. You guys know I'm all about steps. Step number 1. You're going to, let me zoom out so maybe you can see this as we go. But I'm going to go back through this example with you and we're going to work some more. All right, the first step. You want to look at your expression, such as x plus 2, and you're going to find the value of your variable that makes the inside equal 0. This value is called the turning point. So if I'm looking at x plus 2, you can easily see that -2 would make the insides 0. Or like Ms. Rogers likes to say, the guts. So looking to see, and if you can't use mental math, I would rather use mental math to do that, but if you can't, then this is the way you get it. So step one, you just take the insides, set it equal to 0, and solve for your variable. So x equals -2 is my turning point. Now, what the turning point in a piecewise function does, as you saw in the previous video, the turning point is where your piecewise function is going to change behavior. And that's what you're going to use to help you graph the absolute value and the piecewise. All right, step 2. Once you've determined your turning point, then you want to sketch a number line. So we'll put that in there, sketch number line. And to the right of this value, to the right of -2, it's going to have one expression. Either it's going to stay the same or it's going to change based on what we just got through practicing. And to the left, it's going to have another expression. Once again, either going to stay the same or we're going to change it. And that's what I'm telling you here. One expression always stays the same. One expression is totally opposite. So you change it. And the way that you determine this, you test values to the left of your turning point and to the right of your turning point in this expression. So if I pick a number to the left of the number line, such as -3. -3 is to the left of -2. If I plug in -3 into this, I get a negative value. -3 plus 2 gives me -1. Numbers on this side of -2 will make the insides be negative. So we change the expression. And you're going to see what that looks like in a minute. Now, if I plug in any numbers above -2 from the number line, such as 0, 1, 2, -1, I will always get positive inside. So this would be where my expression stays the same. To the left is going to be where it changes. And it's not always that case, so that's why you have to check using mental math, or you can write it down. All right, and we'll keep working that problem here. So at the top, I'm showing you that to the left, this is where it changed. To the left of -2, if I plug in, I get negative values on the inside. To the right, this gave me a positive inside, so this is why I kept it x plus 2. This is how you take an absolute value expression and change it into a defined piecewise expression. So I'm saying the absolute value of x plus 2 becomes x plus 2, meaning it will stay the same, if my values are greater than or equal to my turning point. That will change completely if my values are less than -2, my turning point. Remember, the equality part always goes with where it's going to stay the same. So when you don't change the inside, that's where you always put the equality part. It doesn't always have to be with greater than, it can be with less than sometimes. Okay, I worked one problem for you in your notes, or another problem, but looking at it, I'm afraid it might be too in-depth for you because you don't have to do this much work, okay? You of course need to go through step 1, figure out where your turning point is. So the way I do that, what value would make this 0? What value of x makes this 0? So 3 minus 3 is 0. So my turning point is 3. Notice that I sketched my number line. Always put 3 in the middle of your turning point. Then what we want to do, we want to test some values that are to the left of 3, to the right of 3 in this expression. If I plug in 0, notice that I get positive. So if I plug in 0, -1, -2, I'm always going to get positive values. So it's going to stay the same on this side. So notice that 3 minus x stayed the same to the left. If I plug in values greater than 3, 4, 5, 6, 7 on, I'm always going to get negative because 3 minus 5, -2. 3 minus 10, -7. So values greater than 3 are always going to yield negative inside. So this is where I change it. Notice that 3 becomes -3. Negative x becomes positive x. And so what I'm saying here is that the absolute value of 3 minus x, and this is what your answer should look like exactly. Swirly brace, x minus 3, remember it changed when x was greater than 3. And I told you to always keep the equality part when it stays the same. So notice that when I go below 3, it actually gives me positive insides. So I keep it the same. So 3 minus x if x is less than or equal to 3. Okay, number 2. We're going to do this one together. Don't you love absolute value at this point? I'm sure you do not, but we're going to say you do. Okay, step 1, let's find our turning point. This one, of course, you can always use mental math. 3 times, or you know that 6 minus 6 is 0, so 3 times 2 is 6. But you can always just set the guts equal to 0 and solve, or the insides. So if I set this equal to 0, add 6, divide by 3, that's my turning point. TP. Let's sketch a number line. And you just want to draw your number line out big enough so that you can actually leave yourself some working room. And get used to doing this because we're going to use this method when we solve absolute value equations and inequalities next class. Okay. So we're going to test some values out here. If I plug in numbers below -2, such as 0, so let's do that. We know that 0 is to the left of 2 on the number line. So let's let x equal 0. Then I get a negative inside. 3 times 0 is 0, 0 minus 6. So I get negative insides. So guess what? It's going to change to the left of -2. So to the left of this, I get -3x plus 6. So it changes. And you always drop absolute value, okay? Then let's test some values to the right. So let's let x be 3. If I plug in 3 times 3 is 9, 9 minus 6, that gives me a positive number, and that's always going to be the case. So positive insides, and it stays the same. We're going to leave it 3x minus 6, but this is the way you write your final answer. Make sure that you're going to say absolute value of 3x minus 6 equals swirly. It does not matter which one you put where. So I'm just going to write -3x plus 6 on top. And I'll put 3x plus 6 minus 6. Minus 6 at the bottom. And we have, this is, wherever your turning point is at is always going to be that value. Okay, so when we decided it changed was less than 2. When we decided it stayed the same, and remember, stay the same gets greater, stay the same gets greater. So x is greater than or equal to 2. Stay the same, get greater. So stay the same gets the greater, stay the same gets the equality part. Stay the same, equality. I just threw you all off on that, so that's good. And this would be your answer. Really, it's just that part, but make sure you swirly the two pieces. This is your domain restriction, or where it actually, like you're telling me this because it changes in that location or stays the same in that location, vice versa. Okay, next thing we're going to graph a few absolute value. And I'm going to go through the steps. This is how I want you to show me your work and your homework. So I'll go through the directions that I specified there. Alright, I'm going to go through some examples just like in your homework problems with you. And this is graphing absolute value. Okay, we're going to start off with y equals the absolute value of x minus 3 plus 2. This is actually a simple one to start off with compared to what you have later on in your homework. So your step 1. Step 1. You need to determine, just look at, you want to look at your absolute value part only. Absolute value part only. And determine your turning point. So I'm looking at x minus 3, just that part. My turning point I can easily see is 3. That's what would make the inside be 0, is if x was 3. Okay, step 2. You need to figure out, so you need to rewrite as piecewise. And this is what you're going to do. You're going to rewrite the whole thing. So you're going to say y equals, and we've got your absolute value part. You need to determine when x minus 3 is going to stay the same and when x minus 3 would change to negative x plus 3. And then notice, please don't forget the rest of your equation. You still have this plus 2 that was in there no matter what. The only thing that changes possibly is the absolute value part. Notice that y equals and the plus 2 stayed the same no matter what. Now, if x, your variable, and we have to determine, this is how you pick this part out. So we put our turning point 3 in the middle, and then we're looking at this. So will it stay the same to the left of 3 or vice versa? If I plug in values less than 3, this is going to give me negative insides. And the reason is, like, take an example. Once again, if I plug in -5 minus 3, I'm going to get negative insides. So for this part, we get negative x plus 3. So it becomes negative x plus 3 for that. And that's when x is less than 3. Notice it changed, so I don't put that equality part. I know that this will get the equality part because it stays the same. Now, you can test this. We can plug in, we're going to get positive insides. And the reason is, if I plug in values greater than 3, such as 4, 5, 6, then I'm always going to get positive insides. So in this case, it stays the same. So it's going to stay x minus 3 in that instance. Now, what you need to do is just further simplify that. So that turns into combine like terms. On the top, we get x minus 1. If x is greater than or equal to 3, on the bottom, we get negative x plus 5. If x is less than 3. And then we just go through graphing that like a piecewise. So then that's step 3, is just to graph it like a piecewise. Alright, so for the top part where we have y equals x minus 1, x is greater than or equal to 3, and we have the bottom equation, negative x plus 5, when x is less than 3. So positive 3 here is your starting point, where x is 3. And I can plug in 3 to see where I need to start at. So if I plug in 3 into that top one, I get 4. So 3, so once again, x is greater than or equal to 3 for this piece. I'm going to take 3 and plug in. So y equals 3 minus 1. I do not get 4. So sorry. Y equals 2. So my order pair where I start here is at 3, 2. And that should be, you got that equality part, so this is going to be a closed hole. So 3, 2, closed hole there. Then you can use your slope. Slope is positive 1, and you go up 1 to the right 1. Up 1 to the right 1. Up 1 to the right 1. And why do we go in this direction and not this way? Well, once again, it was x greater than or equal to 3, so you only want to show the right side of the graph. It goes this way. If you graph this correctly, your absolute value graph should always form a V. So hopefully ours does. Negative x plus 5, let's focus on that part. So y equals negative x plus 5, x is less than 3. This, you only want to see to the left of the graph. We're still going to plug in 3 to see where we start. When I plug in 3, I get y is 2. So my order pair, you'll actually find that your order pair most of the time will be the same point. that they start at. Notice this one was 3, 2, and this one's also 3, 2. That should actually work out to be the case. I'm actually going to show you this graph in purple to show you the difference. And I should have put them in different colors to begin with, so I'm sorry for that. But, okay, so we only want to see to the left of the graph. 3, 2 here, this hole would actually be open on the purple graph. I know it's hard for you to see that, but because I already shaded it in with red. But for the purple graph, it would be open. Then your slope for this graph is, look in front of x, slope is -1. So, and you only want to see the graph to the left. So I could go up 1 to the left 1, up 1 to the left 1, up 1 to the left 1 some more, and then draw my graph going that way. And it does form a V. And your absolute value graph should always form a V. Should form a perfect V, and we'll make note of that. Okay, I'm going to stop here for this session, but I'm going to come back and graph some absolute value functions with you, and we'll look at some more in the next session.